Coilovers. Everybody wants them, but not everybody knows what's in them or why you need them. You know who does know? Odi Bakchis.
You know he drifts, but he also makes coilovers.
So Odi's gonna walk us through
basically what we have to think about before we can start putting them together.
Sweet.
So yeah, let's go through it. A coilover is not just the shock, it's the spring and the shock. So we have to choose the right spring, and then we have to build a shock to suit the car and to suit the spring rate that we chose as well. Some shocks already have a spring around the shock, so it's technically like a shock and spring all in one. But a coilover usually allows you to adjust the preload of the spring, which changes the ride height, it changes the droop. It's a tuning factor that you get from a coilover. We can make it all accessible as one unit. That usually is very helpful on a race car where you're constantly changing things out, changing maybe even the spring altogether. It's one unit, you pull it out, you could change the components, put it back in. This is a coilover from a Nissan 240SX. This is a McPherson style shock. That is a coilover with spring preload adjustability, meaning that these locking collars could preload the spring more or less. This whole coilover system is the upper control arm and the shock. This kind of has a pretty big task. It's got to be structurally sound to take side loads and not buckle, not bend, and it has to have a good solid top mount because there's no upper control arm. What's cool about most coilovers out there is that you could adjust spring preload. It does change the ride height of the car, but it also adjusts how much suspension droop you have, how much compression travel you have. And if the coilover kit has this neat feature like this one, you could adjust the ride height of the car by simply turning the lower mount in or out. So you can make the shock longer or shorter. Not all coilovers are designed like that. A lot of them, this lower mount is permanently fixed to the shock body.
And this is all you can adjust on a lot of them.
Yep. If you only allow the customer to adjust ride height by adjusting the preload, you're kind of confined to like a small range of adjustment. Because if you want to lower the car a lot, and the only way you could do that is by taking spring preload out, what's going to happen, essentially, let's just exaggerate this. As soon as the car hits the ground, touches the ground, oh my God, this is a stiff shock. This is a racing car shock. I can't compress this. Yeah. What's going to happen is the spring's going to come down a lot. The shock itself is going to come down and travel, meaning that this shaft is going to get dangerously close to the bump stop. It's all going to be compressed just statically as the car's sitting on the ground.
just from the weight of the car.
Yeah, because you want it to be low, and that's the only way you could make it low is by taking spring preload out. Now, when you hit a bump, you don't have much travel left, and you have an excessive amount of droop, meaning that when you put the car up in the air, or if it jounce over a bump, the wheels are gonna droop out a whole bunch. And I know that some of our customers wanna lower their car a whole bunch, and I don't want them to have to sacrifice shock performance, so this is why you could adjust ride height here without changing the spring preload.
We've got a helper spring, and what do you call this, the main spring?
Yeah, exactly. The helper spring is very useful if the mainspring is very stiff, because if the car hits the bump, it's gonna compress the shock, and then on the upstroke, it's gonna wanna oscillate upward. And if there's not enough mechanical movement left to go upward, it'll top out the shock, and it'll probably be violent and lift the wheel off the ground. It's a placeholder. If I remove this, the mainspring would jiggle around. Okay. It wouldn't locate properly on the spring seats. So this helper spring is basically like someone just holding the spring in place. You could literally compress this by hand. The whole point of this helper spring is to keep the mainspring located in its correct place.
So this is basically the shock of this coilover.
Yep, exactly. This is that important piece of the puzzle that controls the damping. Inside the cartridge, you get the shaft that travels in and out of it. At the end of the shaft, you have a piston. As the piston goes through the cartridge, the oil on one side of the piston needs to make it to the other side, so it flows through these orifices. And as it flows through those orifices, we restrict oil flow by putting these spring steel shims on here. We basically cover up those orifices with these shims, and these shims have a spring rate to them. Okay. So on compression stroke, the shock, as it goes down, it flows through the bigger orifices. On the rebound stroke, it flows through the smaller ones. This stack of shims is for the compression side. This side is for the rebound stroke. Two completely different stacks because we need a completely different amount of force on the compression side and a completely different amount of force on the rebound side.
So this stack sits inside the tube. These will bend
Yep.
to change the speed with which it can compress.
Yeah, it's basically, these are flexing open, and once they flex open, fluid could pass through.
So the top, during compression, these are the ones that bend up.
Exactly. That is awesome that you picked up on it. This is called a compression stack because this is the stack of shims that's responsible for opening up to let fluid pass during the compression stroke. On the
During
rebound,
the rebound, these guys bend.
Exactly.
We're coming through this side channel.
Exactly, yep. A large piston is your friend because a lot of surface area is easier to create that resistance for the shock shafts to follow through. It's easy to create a lot of force. So on a twin tube shock, if you're dealing with a small piston and you try to create a lot of resistance, it just generates a lot of heat.
We're getting into it. The shock's compressing. It is rebounding. We're doing a lot of work in there. We're creating a lot of heat. Do the fluids adjust to that?
So the biggest important factor with shock fluid for a shock tuner, like our company, is the viscosity index of the fluid. So you could use thinner fluid in a shock, it'll make it softer. Sometimes if you're having trouble getting the right force out of it with stacking shims, another trick is to use a different viscosity of fluid to begin with. That's really what separates one shock from another, how much time a manufacturer spent at the racetrack or on the shock dyno figuring out what configuration of these shims work best with what type of piston for any specific car and specific driving disciplines and styles.
Now that we know what goes into all of these, Odi, the mad scientist, is going to show us how he tests out all these crazy shocks. It's shocking.
This is a shock dyno.
Yep.
This saves us a ton of time because we could strap a shock in here and kind of run it through similar paces that it would see on a vehicle. The magic behind the valving is that we custom tailor it to produce a different amount of force at a different speed. You can manipulate that shock in so many different ways. And one way to double check your work, if you actually did it right, is to run it on a shock dyno.
All right, let's run it.
Cool, so let's run at 5 different velocity increments. It's gonna warm up for 10 seconds, just a quick warm up. And then it's gonna go into 1 inch per second, which is a very slow speed. This is the kind of speed that is responsible for the car just slowly shifting weight from one side to the other, maybe getting on the brake and a little bit of dive, also accelerating a little bit of squat. Now it's getting to the high speed. This is when you hit a pothole or rumble strip at the racetrack and it's kind of jolting the shock through a faster shock shaft speed. The top is the amount of compression force. The force is displayed right here. On this axis, you have the velocity. So we ran it pretty fast. It was recording up to 16 inches per second, actually. For this test, we did at quite a few different speeds, and that really helps because it paints a picture of the shock. So this is called like the damping curve. And as it goes faster, as the shock shaft speed increases, it starts to actually produce a little bit less force with higher shock shaft speed. It's not increasing force in a linear fashion, it's digressively shaped. Same thing on the compression side. It's pretty steep at the very low speed compression. That's because we're dealing with a large piston. It's got a lot of surface area to crack those shims loose and open them up. It's taken a lot of initial force to do that. We could make this initial part of the graph mellower by increasing the amount of bleed holes or increasing the size of the bleed hole. Bart, you're gonna make the shock as soft as it can be. So just turn it counterclockwise, and then there's clicks, and basically it will stop turning, and that's when you know it's at full soft. Here's the graph of the shock at full soft. And it is, yeah, so it's still not linear, but man, we took a lot of force out of it. The green is the shock at a stiffer setting, the blue line is at the softer setting. And this is a one-way adjustable shock, meaning that we only have one knob to adjust, and that one knob in our shocks adjusts the compression side and the rebound side as well. The shape or the curve is kind of similar between being very stiff and very soft. The curve of this graph is something that we designed, like we can make this particular shock be progressive, but we don't want that. Like for this particular application, we wanted it to have a slightly digressive curve. We wanted the compression to be fairly linear from like mid-speed to high speed. We wanted to have a little kick at the very beginning.
And progressive means we'd look like that?
Yeah.
So that means we would have less force on rebound at slower speeds and more at faster.
Yep. So it went from 516 to 619. You will definitely notice that as a driver going from one setting to the other. We got a lot of wiggle room to make some really cool changes, but if you don't know what you're doing when you're putting a shock together, you could really make the car handle worse than it did from the factory. And that's where the consumer has to be pretty careful about what coilovers they choose, because as a coilover tuner, you have the ability to manipulate the shock to do various things. You just got to understand that you can make it worse or you can make it way better.
And so we adjusted the damping for the dyno, and Odi's going to walk us through what we just did.
When we're talking about the piston and how it restricts oil flow, we could actually bypass the piston. There's two little holes. There's one right there, another one right there. And what that is, it's a bypass around the piston. It's kind of like the garden hose at your house. You know, you could open it up so you get like a little stream coming out, or if you really want to blast something, you open it up full blast. So that's essentially what you're doing.
It's also pretty crazy to think that this hole is responsible for 100 pounds of pressure on recoil.
Yes, it seems like insignificant size, right? It's like a 3mm hole, and there's two of them, so it's 6mm of total orifice, but there's a ton of fluid that you could run through there.
And it's kind of this is about where it sits, right?
Yep.
So you're out, and it goes through the hole, and then you're closed.
Yep.
And it goes around it.
So you could keep track of how much you're opening it or how much you're closing it. We made it so there's indents. So as you turn, there's an indent. We also call that a click. So when your friends are like, hey, adjust the clickers or how many clicks soft or hard you are, that's what they're referring to.
30.
So what that's doing is basically allowing us to, instead of going inside the shock and taking a shim out or changing the piston size, we could just turn a knob and we're increasing the size or decreasing the size that oil is flowing through, and we're changing how much force the shock's making.
Let's say somebody's looking online and they want coilovers because it looks sweet. What should they look for to be like, oh, this is legit, or oh, this is just aesthetic?
Someone's buying a coilover, and online in photos they look very similar, and some look really cool and colorful, and sometimes they get the job done of lowering the car. But always realize that the shock part of it is so important, and you got to make sure that the product you're buying is actually going to make the car handle better, not just lower it aesthetically. So just ask questions of the manufacturer, like, hey, what kind of piston do you use? Is it D-shaped? Is it a small orifice, large orifice? And if the manufacturer is kind of clueless about what you're asking, that's probably a good indication that they probably didn't put the R&D and time into developing that shock. Maybe it's just a shock that aesthetically looks cool and might lower your car and do just that.
Does it make sense?
So if you're thinking about modifying the suspension on your car, if you want to lower your car or just want it to be more responsive, you got to choose some good coilovers, because you got to have the adjustability, and remember, you got to have the firmness if you're going to drop the car so you're not blowing through that suspension stroke.
So you don't just want to cut the springs on your OEM.
No, that would be a bad idea, Bart.
Nolan. Subscribe to Donut. This little button out here is a subscribe button. Let's say I want to get my hands on some of these sweet, sweet coilovers. Where would I go?
Fealsuspension.com, and there's links and descriptions of all of our different products.
Follow us on Twitter and Instagram at Donut Media. Follow me at BidsBardo. Follow Odi
At Odi DRIFZ, but follow Feal Suspension at Feal Suspension.
Don't tell my wife me and Eddie are about to go hit the slopes.